Hi, everybody. So my last name is spelled as Akkiraju. By show of hands, how many of you can speak 3 or more languages in the room? Oh, wow. OK. That's quite a few, more than what I expected, but that's great. Language is hard, right? Mastering a language is pretty hard, especially if it's a teen language. As a mother of a teenager, I know all about it. I go, what? That word means that these days? Now, imagine we have to teach that language to AI machines, and not only the language of the humans, but the language of the enterprises. So today I'll talk more about what it takes to teach AI systems the language of the humans and as well as the language of the enterprise. So Polyglot Enterprise AI is the title of the talk. What is a polyglot? A polyglot is a person who speaks multiple languages. So we're here talking about AI systems speaking multiple languages. So here are the key takeaways in case you missed the rest of the talk. To build Polyglot Enterprise AI, AI needs to be able to master not only the language of the humans, but the language of the enterprise. And I'll show that to you with more examples. And the second one, you don't have to perfect the language of the humans in order to really begin to address the language of the enterprise. There is no shame in really narrowing the problem and solving the narrow AI first, as opposed to trying to attempt to solve the broad AI. And the third point is that depending on the availability of the amount of labeled data and the transparency and such requirements that you have, you may have different options at your disposal. And I would like to take you through some of those, what those options are today. So let's look at the language of the humans. How many languages are there in the world? So I'll give the answer. About 6,500 to 7,000 plus languages, apparently. And 23 are the most spoken languages in the world. And typically, businesses do companies do business in about 170 plus languages. So this starts to give the scale of the problem. 170 plus languages is what companies have to master. AI systems have to master in order for their systems to be really available in all those languages. So let's take a look at the complexities of understanding human language. I took one NLP task, which is the machine translation, and wanted to demonstrate what it means to really understand human language. Take some idioms, humor, and sarcasm, and throw it in any favorite translator, machine translator program out there, and you'll be surprised. And I'll pick one. I picked Telugu and Hindi languages because those are the 2 languages I speak in addition to English. So I'll take you through this one example. Hit a roadblock. It's an idiom. The translation is pretty funny for those of you who speak Hindi audience. In the audience, ek sadak mara. It's utterly ridiculous translation. Selling point. Take that for example. Vikray sthal. It's literally translating to the place where things are sold, as opposed to really understanding the meaning of the expression selling point. So language is hard, and through social media and lingo and other things that keep changing every day, it's pretty hard to keep up with it for AI systems. Now we have to add 170 plus of these languages. So let's take a look at how we're doing actually. When we look at the current progress in the space of NLP, 2019, I would say, is a defining moment. If you look at some of the leaderboard tasks on NLP, I'm showing here some of the basic tasks, and it appears that computers are actually surpassing humans in some of the basic NLP tasks. I won't go through all of these, but the black line is the human, and glue score is the one that's primarily used, the dotted blue line. And there are many tasks that are out there on leaderboards with different data sets, and people are attempting so many different algorithmic techniques to attempt at those different tasks, and they seem to be doing pretty well on those. Does that mean that we are actually mastering human language? How close are we to really understanding human language, or how close are the AI systems to understanding human language? First of all, we should understand that glue score is a very poor representation of all of the human language understanding. It's one representation, one measurement metric that has been chosen by the NLP community, but they themselves would admit that that's not a very good score. It's only limited to actually classification tasks. It doesn't really represent some of the complexities of real human language. The question answering pairs, sorts of data sets that are given are very simple, and they don't represent the business world also. And mostly these competitions and leaderboard things are limited to English. They don't scale all that well to other languages. So that's that. That's about the language of the humans. Now, language of the enterprise. Let's look at what does it mean. Companies are applying AI to various different types of domains, right? For building chatbots, for building doctor's assistants, for in legal domain, healthcare domain, financial domains, and so on. So many different domains, and they all have a vocabulary of their own. We don't encounter as many of these vocabularies in regular human language. So let's take this example. I don't want you to read all of this. Just focus on some of these yellow highlighted words. The one on the left is the doctor's note on a patient, and you see words like meloxicam, lower sternum, troponin, acute coronary syndrome, ulcerative colitis, and so on. How often do you encounter that in regular human language? And the one on the right-hand side is a corporate contract. And here, there are a lot of things about who owes what to whom by when, sellers, buyers, their rights and obligations, and so on. If we throw in a regular NLP task that masters one of the question answering systems at either of these two examples, they'll fall flat on their face. No hope, no chance, because they don't understand the language of the enterprise at all. But if you look at the language of the enterprise, it's very, very hard. It's complex. There is not that much labeled data that's available. There are a lot of privacy restrictions that really prevent data from going outside to really leverage crowds at large to get the data labeled. Of course, they require multilingual support. There is a lot of special vocabulary. Subject matter expertise is required. And their subject matter experts are not programmers. Therefore, they can't really just simply go in and write some additional expressions and such to add these vocabulary into the system. So enterprise data is complex, and it's tucked away within enterprises, and it brings its own sets of challenges. So when I say polyglot AI, I don't necessarily just mean multiple languages as in the language that we speak in 170 plus. It's the language of the enterprises, like these kind of things, of the contract understanding, of understanding the vocabulary of healthcare domain, of retail domain, financial domain, and so on. So there comes the first key takeaway, right? It's polyglot enterprise AI especially needs to be able to speak not only the language of the human, but the language of the enterprise. So understanding human language is hard, we said that. But understanding enterprise AI, making AI speak enterprise language is even harder. So, but how do we make progress? Are we at logjam? Are we stuck? Well, here is where, there is an insight that came to us as we were working on this. How about, instead of trying to really address the broad AI, in the case of NLP, it's about really these systems being able to do Turing machine type of tasks, right? Being able to really, do the broad AI. But how about, we don't necessarily have to solve all of that. How about we narrow the domain and really be able to address the specific problem at hand and address that? And as long as we are able to excel in that domain, it's fine, even if we don't solve the broad AI, right? So narrow the problem down, and it may not have to be, really passing the Turing test. It could just be, does it understand on top of basic human understanding that it has, if it's able to pick up enough domain expertise for a particular industry? Maybe that's just fine. That's the narrow AI. And you take it to a particular enterprise and actually deploy it there and let it further customize and learn from that particular enterprise's language for that particular company. It gets even better. And that's absolutely fine to address that narrow AI. There is no shame in actually solving a real problem instead of trying to attempt the full broad AI. And if you look at the learning curves, you can actually start to ride these learning curves by reducing the amount of training data, labeled data that you need, because you're narrowing the problem. So you can accelerate learning faster. So now let's take a look at the same two examples that I gave earlier. If we just applied the base human language understanding speech system and gave an audio spoken by a doctor, in the first iteration, it made the following mistakes. Where it said lower sternum, it ended up transcribing it as lower stardom. Where was it supposed to be troponin, it ended up saying proponent. And for acute coronary syndrome, it heard it as good con R syndrome. For ulcerative colitis, it said a full sort of colitis. So few mistakes it made because it didn't have full understanding of that particular domain. All we had to do was to take that piece of text with the correct transcription, just that piece of text, and customize our speech machine and rerun it, and there you go. All those mistakes that were in red now turned green, and the system was able to pick it up. So this is the power of really customizing and narrowing the domain. All you had to do was have a base layer that's good enough, and then start to customize it to a specific domain. So again, I'm not giving specific experimental results here, which I will in just a bit, but intuitively, what this told us that you don't have to really perfect the language of the humans in order to really attempt to solve the problem of the enterprise AI. You could actually begin to do it by narrowing the domain and solve the narrow AI, and you would get pretty good results and that are practical enough for you to use in enterprises. So now I want to talk about what does it really take to build these polyglot systems. In NLP, for natural language understanding specifically, there are 3 different techniques, broadly speaking, you could say. There is statistical approach, there is the rule-based approach, and then there is a third one, which is an interesting one, a human co-creation approach. And I'll take you through what these are. Statistical NLP is pretty much machine learning. Everybody talks about it. It takes a lot of labeled data and processes the data, learns the patterns, and produces prediction models, right? So in a conventional approach, if we were to build a polyglot AI model, what we would do is we would be taking English data, labeled data, to build an English model. We'll be taking German data to build a German model. We'll be taking Chinese data, labeled data, to build a Chinese label model. This is how we were doing it pre-BERT, right? The universal language model. Of course, that's very inefficient, highly not cost-effective, cumbersome, so many models to manage and maintain. Thank God we have BERT now. We have this multilingual model. We can train it with massive amounts of Wikipedia data. Now we have one universal model, throw in all kinds of labeled data into it. Out comes one cross-lingual model that we can use and deploy, one model to manage and maintain, right? So the broad AI solution for it is throw in Wikipedia data, because it's parallel data in different languages. You throw in and the system learns the word embeddings and the associations between words in different languages, and it's able to make this cross-lingual model. That's the broad AI. Now, what we want to be able to do is to take that pre-trained BERT and actually on the top layer, really start to now add this additional data. Think about this as the narrowing or the customization that I was talking about in the triangle. So the top layer is now a fast-forward neural network, or feed-forward neural network, and with softmax, and we start to feed in the specific labeled data of a particular enterprise or a particular industry on top of the pre-trained BERT to now start to customize it further. So here is an example. You could take English insurance companies for customer support domain, very specifically, and start to feed it in through on top of the pre-trained BERT. And throw in different languages, say German companies, customer support, insurance domains data. Same thing for Chinese and so on. On top of the pre-trained BERT, now we get one cross-lingual model for insurance industry and for customer support use case. Specific, right? Very specific. I want to be really specific because that's the problem that I want to solve. I don't particularly care to solve Turing machine problem here. Now, we could go one step further and say, okay, there's a particular company called ABC Insurance Company, and they want to deploy their customer support chatbot. Now, I want to further customize this model for them. So now, again, the same idea, take the universal NLU model you have, the insurance industry specific model we have, on top of it, throw in this additional very specific company specific data, the softmax layer on top. Now you get another model out, and this is the statistical NLP. So we applied this to our sentiment model just to test it out to see how it works, and I'll just present these examples. So we threw in English, Spanish, Italian, Brazilian, Portuguese, and so on, eight different languages labeled data. And the first column in the table talks about the accuracy when you build it with one single model. That is, take English data, build an English model. Take Japanese data, build Japanese model, not using BERT, right? So that's the accuracy. Whereas the third column on there shows really with the BERT model, language independent model, what happens if we try to make a sentiment prediction across these three labels, positive, negative, neutral, the accuracy numbers. So obviously this is showing us that it's pretty encouraging, pretty good. our accuracy is on par or better, so that's great. BERT model is working. Now we wanted to see, what can I do zero-shot learning? That is, without actually feeding any labeled data in a particular language, can I actually make the model predict in the sentiment in that language? Now that's an interesting thought. How could you actually make predictions without giving any labeled data whatsoever in a machine learning model? Well, that's the power of BERT and statistical model here, where you have word embeddings from multiple languages that are pre-trained. It so turns out that when we try to make a prediction in French with zero-shot learning, we are not bad at all, about 57% as compared to the 54% when you actually train a French model with labeled data, a single model without using BERT at all. And on top of it, if you add some labeled data, it increases further to 64%. So that's pretty encouraging to start with. Of course, if you add more labeled data and if it saw more instances, you'd probably get better even further. So what's the problem? Why can't we just use this? Well, the problem is statistical NLP requires large amounts of labeled data. It's impractical in many domains, like the contract understanding domain that I had just shown. And it's not very transparent and it's not very explainable, right? So the example on the left-hand side may be addressed with statistical NLP, but the example on the right-hand side cannot be, because you cannot get so many contracts from a company be labeled by experts to tell you exactly who owes what to whom, so that the system gets enough understanding to learn patterns. It's too much to ask for. So that's where rule-based NLP comes handy. Right? Rule-based NLP is talking all about these different kinds of NLP stack tasks that you have already, like sentence segmentation, tokenization, part-of-speech tagging, lemmatization. Keep on building on that stack, and have a subject matter expert use a rule language to write rules. So you're actually able to tell the system that this verb, when it's followed by this kind of an entity, this is what it means, and it's considered to be an obligation in a particular domain, and so on. And you go further and use semantic role labeling, to really identify who owes what to whom, or who did what to whom, when and where. And use preposition banks from different languages, and start to build out this cross-lingual or multilingual information extraction, and apply that to specific domains where you don't have too much labeled data. So a rule that's built with an SQL-like query language that was developed at IBM Research called annotation query language would look like that on the top right corner. And if you take the text on the left-hand side and run it through that annotation query language, you would start to actually derive things like what you see, what's an obligation, who's the purchaser, whether it's a purchase or not, and so on. So this is what is the rule-based one giving. However, these are complex to write, right? We have to really train people to write that SQL type of languages. So there are disadvantages to this approach too, in the sense that it's helpful, useful to do large amounts of training data with small amounts of training data, but you cannot really have a subject matter experts write those rules. So the third approach that we have come up with is human rule co-creation. Basically use deep learning algorithms, machine learning, statistical NLP, to train rules and expose those rules to humans so that they don't have to have the burden of writing the rules, but the rules are written a priori that they can then correct. That's the human co-creation learning approach. And when we did tests with that, actually it does pretty well when humans are refining the rules that are already done by machine learning models. So to summarize, I would say, I've presented 3 different approaches. Each of them have different pros and cons on their own. But you have to really pick and choose based on your needs. So to sum up, the key takeaways for building Polyglot Enterprise AI, you have to really make sure that the systems understand not only the language of the humans, but the language of the enterprise. Also, there is no shame in solving the narrow AI, as opposed to trying to do the broad AI. And also, depending on your availability of labeled data and what are the transparency requirements that you have and such, you may have different approaches at your disposal, like the 3 that I mentioned. So you may want to consider those things as you are building Polyglot Enterprise AI systems.
Thanks very much, Rama. Wonderful talk. Thanks. Great.